All right, here we go. Implicit versus explicit differentiation. So guys, you've been doing, without realizing it, you've been doing this kind of differentiation so far. Because it's explicitly been given to you with f of x or y all by itself. You've seen this since algebra 2. F of x equals this. Y equals this. So I want you to think of implicit. So when y is given to you, it's like y-intercept form. Okay? But implicit almost feels like standard form. Y is not alone to start off. But you can derive without getting y alone. You with me? Because sometimes, look at these. If I ask you to solve for y, get y by itself, you can't. With any of these, you cannot get y by itself per se, without it being a total nightmare. Okay? So, what you've been doing is, you've been getting, I know you've been given it, but it's like getting y alone first, and then to the taking the derivative, deriving from there. Implicit, you derive first, right? And then guess what you get by itself afterwards? Not y. F prime of x. Y prime. Okay? So get f prime by itself, or alone. Alright. We good? So, y cubed plus y squared minus x squared is equal to negative 4. I'm going to derive or differentiate with respect to t. So another big thing that you're about to learn is who gets the respect. You've been given the respect right now without realizing it to x. So whenever I tell you take the derivative of 5x, you're taking it in respect to x. In other words, what's the derivative here, guys? 5. But if I told you to take the derivative of the same thing, but let's say that I was talking about in respect to t, it's not going to be 5x, it's not going to be 5, it's a little bit more involved than that, okay? First of all, let's look at 5 in constant multiple rule. We're going to move it out of the way, okay? It's almost like factoring it out. What's the derivative of x if I give the respect to t? It's dx dt. Okay? And you'll see in just a bit. You can't just get it from one example. And then you move the 5 back in there so that this is the derivative of 5x if you take it in respect to t. Okay? Again, you're not going to see it from one example. Let's go back over here to my original one, though. Okay? If I derive this with this approach, I would write 5 times the derivative in respect to x of x. And what is the derivative of x in respect to x? It's dx over dx. And what's dx over dx cancel to? Just 1. And 1 times this 5, that's why it's as easy as just saying 5. Okay? So when we take a derivative in respect to a different variable, we have to do this piece interpretation. Believe it or not, you've been doing it, you just didn't realize it. You've been doing dx over dx all this time. Because it just one's out. Okay? Yes?
What if you have to mix of different variables?
We'll get there. We'll get there. So, right here, this is saying you're going to take it in respect to t. Here we go. What would normally be the derivative that you're used to? What would you normally say as this? 3y squared. But now I want you to think about it like this. Chain rule. It will be 3 of the stuff squared, but then we have to multiply by the derivative of the cream. We have to multiply by the derivative of the chain in respect to t. So the derivative of y in respect to t will be that. Chain rule is huge. You need to master chain rule to even have a shot at implicit, okay? So this will be 3y squared dy dt. Okay? Plus, what will the next one be? 2y times what? dy dt. Minus 2x times dx over dt is equal to 0. You with me? That's where we're going to start for right now. Are there any questions? All right, so let's look at another example, and you'll start to see what in respect to really means, okay?
Is that the final answer?
That's it for now, yeah.
Oh, okay.
So here we go. We're going to take the derivative of the same function, but in respect to w. Okay? Grant, can you sit here, please?
Yeah.
In respect to w, what's the derivative going to be? What is the derivative of y cubed first? 3y squared times dy dw. Okay? Plus what? 2y times dy over dw. And then minus 2x times dx over dw. You're not putting 1 because you haven't yet experienced dw over dw. So you still have that little differential piece, is what it's called, with this implicit differentiation stuff. Is equal to 0. Okay? Now you're going to start to see what this looks like here in just a bit, because we're going to go back to x. Luke, what's the derivative right here?
3y squared.
3y squared times?
2y.
No. Before that? Someone help him out? dy over dx. Okay. And we're going to add, try again, Luke.
Then we're going to add 2y, and then times dy dx.
Yep. And then, Drew, it'll be what?
Negative 2x.
Yep. Times? Yep. The derivative of x in respect to x, which you've been seeing as 1 this whole time without realizing it.
Yeah.
Okay? Is equal to 0. So yes, you really don't even need that because it's just 1. Yes?
What's the original equation set equal to -4?
So it's set equal to -4 because it's implicitly given to you. It's not given to you in y alone form. It's given to you like we were showing at the beginning with standard kind of form versus y-intercept. It's given to you in a different form. Okay, y is not alone. All right, so now, here's the thing. My dy dx's, let's solve for those. Because remember, I told you our goal is to find the derivative. You know the derivative as this. You also know the derivative as this. This means the same thing, and so does this. All of those are looking for the derivative in respect to what variable? X. Okay? So looking at this, if my goal is to get dy dx alone, look at implicit differentiation. You have to derive first, then get the derivative alone. And this is basic algebra 1 from here. How do I get dy dx alone? Move the 2x, yeah. So we're going to move the 2x by adding it to the other side. And it becomes a positive when you move it over. 3 letters. What do I do? GCF. GCF will determine whether you struggle on this unit with implicit differentiation. Because now I no longer have 2 dy dx's. I only have 1. And that's the goal, is to get the derivative, which is this, all by itself. Yeah?
Two things. So do you always just manipulate the dy or dx or whatever it is, just like a variable, like one thing?
Yep.
Or is it like, okay. And then also, what happened to the -4? Like, I know you guys are
It became 0. Originally, when we derived the first step,
it's just
the
a-
derivative of any constant
I get it.
is 0. So now when I move over everything, I'm going to say dy dx is equal to a 2x over this entire thing that I divided by to move it over. So here we go. This is my derivative. And you've been doing derivatives now for a good, what, month and a half? Almost 2 months. Well, per se. What's different from what you see here that I boxed than what you've seen so far? 2 variables. So if I gave you a point like find the derivative at 1, you're used to doing this. And you would only plug in the 1 into your function and you'd get your derivative. But now, that's not the case. Because now I have a y value that I get to finally also use so that I can get the slope at that point. Are we good? Okay, let's keep going. Alright, so now I'm going to start calling out on you, please. Just follow along. Even if you don't know, please don't say I don't know. Please say what you think, okay? Alright, so we're going to find the derivative of this in terms of x and y. So that means we're going to have x and y's left over in our answer, just like what we did just now. You saw an x, you saw a y. Alright. Should I implicitly solve for this, or should I explicitly solve for this? Implicitly. Because if I had to explicitly solve, I'd have to get what by itself first? Y. And I don't want to do that. I'll just get y prime by itself later. Okay? So here we go. Listen, I'm in respect to x. I'm giving x the respect. Okay? So anyone, what's the derivative of my very first term that is x squared? 2x. That's it. Technically, it's times dx over dx. Right? But it's 1. We don't need that. Okay, if you want to write it for your notes, go ahead and do that. But it will make it 1. Now, adding the derivative of the next step. Kevin, what's the derivative of x times y? What are you thinking about? What rule have you learned that you're thinking about?
So
Product.
X times
So first times
dy dx.
dy dx, the derivative of the second,
plus y
plus y times
dx dx.
dx which you can write, or you can write it as 1. Now, right now, that is the derivative, but I think it's missing one parenthesis. Do you agree? I think it should be this, because what if you had a 2 here? You would have to distribute the 2 on both. What if you had a negative? You would have to distribute the negative on both. So even though we don't necessarily need it for this one because it's just a positive 1, still get in the habit of using those brackets. Okay? Nice job, Kevin. All right, so Saeed, what would the derivative of the next one be? 2y times dy over dx. Perfect. Drew is equal to what? 0. Cool? Now, we just derived first step. The next step is to get what by itself? dy dx. Okay, so John, let's start moving this. So I'm going to make this 1, just so that people aren't confused. And John, how would you move this?
Subtract the 2x over.
Subtract the 2x over. Would you subtract anything else over? Okay, so we got to look at parentheses. He's not alone. This is what I was wanting to stress. Simplify a little bit before you start moving stuff, okay? So here we go. If I simplify this, I'm getting rid of parentheses. And the next question that I would ask, if you understand where I'm going with this, what would the question be that I would ask right now to check? Wait, what? No? How many terms do I have? Okay? I have 4 terms, and 2 of them have dy dx. So if you want to save time and really reduce the amount of work that you're going to do, I would subtract the 2x, I would subtract the y, and I would also GCF the dy dx all in the same step. If you don't see that right now, then do it by hand one at a time, okay? So here we go. Subtracting the 2x over, subtracting the y over, and GCF outing the dy dx. Can you tell me what would be left over in parentheses? Yes, x minus 2y. All we've done is basic algebra 1, and then GCF, which is still algebra 1. And what am I finally going to do at the end? Divide by x minus 2. So negative 2x minus y over x minus 2y is equal to the derivative. In terms of what? X and y. So guys, you are learning 2 big things today besides implicit differentiation. I feel like you should learn this back in algebra 2. In terms of. And this is what you're learning right now in respect to. You with me? Let me help you out. C is written in terms of what? R. Good. A is written in terms of R squared. No, not R squared. Just R. You're just stating the variable. But what people will mistakenly do, and nice job, they'll say it's written in terms of pi and R. But you can't do that because pi is a what? Constant. Okay? Then you have A is written in terms of L and W. Go with me? So, and then in respect to is what you learned today. who gets the respect so that it will 1 out and cancel to a form of 1. Yeah.
How is the derivative of y just dy over dx in the first step? For the product rule.
It's because like the x like.
Okay, because you have the first times the derivative of the second, and all of these were the derivative of whatever that variable is in respect to x. So the derivative of y in respect to x would be dy dx.
Okay.
So it's the first times the derivative second plus the second times, if I do this, it would 1 out. Are we good? All right. So that's the final answer.
Each one of these students need to get this back.
Okay, so now let's move on to something with trigonometric functions, okay? Again, I'm not going to get y by itself. That would be a nightmare. But my goal is to get dy dx alone with x's and y's over there to the right as variables in terms of, okay? All right, so let's go with deriving what we see. Adam, start us off. What rule are you looking at to use? Product. Here we go. So what's the first?
Do the derivative first, negative sine x.
Okay, so we usually do first times the derivative second only because of consistency. I'm going to do it like that for the video.
Okay.
So the first times the derivative of the second, which is what?
Cosine
Okay, go for it. Cosine of what?
y
Cosine y
times the derivative y dy over dx.
perfect. Before, that used to just be 1. But it's not 1 because you're taking the derivative of y in respect to x. You with me? So it's the first times the derivative of the second plus the second times the derivative of the first. What's the derivative of the first? Negative sine of x. And yes, technically times dx over dx, but it's going to 1 out. Okay? Is equal to 0. What's the question that I would ask myself right now? How many terms am I looking at? 2. So all I need to do is subtract one of them over and then divide. Or alter from there. Okay? So here we go. So cosine of x, cosine of y times dy dx, I'm going to move over this product, and when I move it over, will it be positive or negative on the other side?
Positive.
It'll be positive. So it'll be a positive sine x sine y. Because you remember, right here, it's a negative. So I have to add it to the other side. Okay? So when I add it to this other side, this negative will become a positive, and this is what I have right now.
So what's the plus?
Why is what plus?
Because you just didn't.
Oh, because you did product rule. First times the derivative of the second plus the second times the derivative of the first. Okay? Now, to get dy dx all by itself, we're going to divide by cosine of x, cosine of y. And your final answer will be dy over dx is equal to this, and you would get full credit on the test, but you wouldn't get the bonus. What could you do to get the bonus? Tangent x, tangent y. So dy over dx, tangent x, tangent y. Okay? Alright, so now, what I want you to do with your new groups, and I will show you the answers whenever you finish. I'm going to give you probably like a good 6 minutes. I'll give you 7 minutes. I want you to do A, B, and C, and I will meet you at the end. Alright, resuming the video. We are going to look at the key to what this is. Just want to make sure I'm in the right place. Here it is. Alright, ready? There is the answer. The first times the derivative of the second. So there's the first times dy dx plus the second times the derivative of the first plus 3 dy dx minus 10x is equal to 0. Notice that I counted how many terms do I have as far as, I've counted how many terms do I have so that I can see what's going to move to the right. Subtracting the y, adding the 10x, GCF adding the dy dx, and dividing x plus 3. So if you got the first one, give yourself 10 points. The second one would be 14/5. And the last one would be y minus 6 is equal to 14/5 times x minus 2. Okay? Alright, resuming the video, we are doing our next example. It is finding the second derivative. That's how you notate the second derivative. I know it's weird. There's no reason why they do it that way. But it's d to the second. You're not squaring anything. It's just saying that's how you find the second derivative. If it was the fourth derivative, it would be d to the fourth y over dx to the fourth. That's just the notation of f double prime. So in groups, my suggestion to you is make sure you write your answer in terms of x and y, and only those variables. Go for it. Alright, resuming the video, we are going for the key. Should move down. Alright, so the big part of this was keeping parentheses organized, making sure you were good to go as far as in terms of, and this is what you should have gotten. So there's the original problem. Okay? It is 2y dy dx plus product rule, see the parentheses. I counted how many I had, subtracting the y, GCF, everything else. This is what you should have gotten for this. If you got it correct, give yourself 20 points. Now, listen. Quotient rule from here is low d high minus high d low over low low. If you got that, give yourself 20 more points. However, I told you to write it in terms of y and x, not in terms of y and x and dy dx. So you have to resubstitute everywhere where you see a dy dx with just this stuff up here. So that everything at the very, very bottom will be just in terms of x and y. You'll see that on the test. So, if you got that last one, I want you to add 2 more. So, if you're perfect, that's 60 points, which is a grand total of 120. But otherwise, it's either going to be 20 or 40. Okay? Alright, real quick. Here's another problem. Your next problem, we have like 2 more problems. Find the second derivative of that. Again, the warning is only in terms of x and y. 6 minutes. So recording again. The derivative of what we had would be 0. Notice my use of parentheses with the product rule. Minus parentheses the first times the derivative of the second plus the second times the derivative of the first. And then the other side was 1 minus dy dx. Then I simplified it and I saw I have 4 terms. I have 2 on the left, 2 on the right. So I will add the y to the right side. I will add the dx dy, or sorry, dy dx to the left side, and then you saw that I GCF. Okay, and the GCF would give me dy dx times 1 minus x, 1 plus y. Now, some of you might do something different. So what I'm about to do is I'm going to ask you, right now, this is the answer. 1 plus y over 1 minus x is dy dx. But here's the thing. Some of you might do something different, and you would get this answer, okay? And then I want you to tell me why they got this answer. You'll get something like that. Guys, that is the same exact answer. Why? Because it's a multiplication form of 1. If I multiply the top and the bottom by a negative 1, this would distribute, becoming this, and this would distribute, becoming this. But they're still the same exact answer. When you plug it in, it's like y2 minus y1 over x2 minus x1 is the same as y1 minus y2 over x1 minus x2. Okay? Yes, Nathaniel.
How does the 1 minus x?
Because I'm multiplied by a form of 1. An alteration could be this. So if I distribute, I get a negative 1 minus y. If I distribute, I get a negative 1 plus x. These two are the same. Okay? Oh, I'm not there yet. I haven't done question rule yet. Okay, so that all was the first part, 20 points, okay? Here we go.
So I wrote down y plus 1 over negative x plus 1, and I saw the two ones, and
That's fine.
I canceled them out to just get y over negative x.
You cannot do that. Guys, listen. Shh. Drew just volunteered a good mistake. Alright, so, real quick. Drew wrote this down. And some of you will do this as well. He said he wrote y plus 1, is that what you said?
Yeah, y plus 1 over negative x plus 1.
Okay.
So I just put it in a different order.
Now, he has y plus 1 over negative x plus 1. That is correct. But he did something that is a huge no-no. He tried to cancel those two out. You cannot cancel between addition. You can only cancel between multiplication. Okay, no worries, no worries. Alright, let's keep going. So low D high minus high D low, quotient rule. That's what you should have gotten. If you got this line, give yourself 20 more points. But I asked you to give it to me in terms of x and y. This would be the third one, the 60. Okay? Alright. Yeah, the D low because it's 0 minus 1. Alright, guys, listen. Shh. Now that you know your points, for extra bonus points, the first one who finds it, I want you to tell me what's wrong. What's wrong with what Matthew has?
Extra y.
There's y and there's y on the other side of the equation.
The biggest thing that I noticed immediately was this. Like you guys might be looking at other things right now. What is that? Because if that's not there, this will not distribute. That is a huge common mistake. Like 90% of people make that. Okay? So that's all I wanted to bring that to your attention. And he just reminded me earlier than what homework would have done. So parentheses on that. Otherwise, if you did not have parentheses, all you're really doing is multiplying those two. You see what I'm saying? So if anything else was wrong, the one that I was looking at was a parentheses. Any questions? Okay. So what you just did, as an example, you will have second derivatives, but you will also have them to where they ask you at a particular point. So they could give you x equals something or y is equal to something, and it's at a particular point. So what we're going to look at right now is we're going to start this one off, and I will let you finish it off, but we're going to start it off together, okay? It says, again, we're going to do this together.
Mr. Travis, can I grab a notebook?
Oh, yeah, sorry. Where's it at?
It's on your desk.
Oh, yeah, go for it. Thank you for letting me use that as an example. All right, here we go. Consider the curve. So this is not a function. It does not have to pass the vertical line test. Consider the curve that you see here, and we're going to find dy dx. So we have 3y squared, chain rule dy dx, plus 2y, chain rule dy dx, minus 5 dy dx. And some people kind of, it looks easy, but struggle with that. My best suggestion is move the 5 over to the door, near the door. Just move it out of the way. Constant multiple rule. And what's the derivative of y? dy dx. Multiply the 5 back in. Okay? And then, anyone, what? 2x is equal to 0. You don't have to do the times 1. At this point, now we know what we're doing with implicit differentiation in that respect to. So we could just leave it. We don't have to write it as 1. And now my goal is just to get this all by itself. And what question would I ask myself right now? How many terms do I have? 4. 3 of them have this GCF'd out. Moving the 2x, we're adding it to the other side. And then we're left with 3y squared plus 2y minus 5. And yes, you're just going to divide everything by this 3y squared plus 2y minus 5, and this is my derivative. So then I will plug in, it says write the equation of the line tangent here. So 1 will go here for x. Negative 3, be careful with parentheses, will go there for y. So it'll look like 2, 1, 3, negative 3 parentheses squared, plus 2, negative 3 in parentheses. These parentheses are important, especially because of that square piece. So this is important, otherwise you're going to get it wrong. So that you would get, what? 927 minus 6 minus 5. So that the derivative would be what? 1/8. 2/16 or 1/8. Okay, so I have the slope now. I have the m. Okay? And what I'm going to do is I need to know what point I'm using. That it will be the equation of the line tangent to the curve at this point. So from here, I'm just going to do minus 3, so it's going to be y minus a negative 3. So 1/8 x minus 1. Easy enough. Okay? But for the last part, look at it very closely. We have enough time to finish this off. Find the coordinates of the points of the curve where the line tangent to the curve is vertical. So on the original derivative, I want to know when it's vertical. What does that mean? when the denominator is 0, because that makes it undefined. So you have to, I'll set you up, let you finish it off on your own. You have to find when is this equal to 0. So if we did 3y, y, we have 5 and 1, we could have something that looks like this. It will make the 3y squared happen, it'll make the negative 5 happen, and most important, it'll make the positive 2y happen. So don't put up yet, please. Then we'll get y is equal to negative 5/3, and y is equal to 1. Those are the places where it could have a vertical tangent. You with me? But you have to plug these in to the original equation where you see y and solve for x. So when you do that, you're going to get two answers for this one. You with me? And then you're also going to get two answers for this one because it is squared. Those are the heftiest ones that will be on the test. Okay? All right.